Our next presenter will talk to us about a topic that is near and dear to the hearts of a lot of Water Online users and listeners, and that is PFAS. And here to tell us more is none other than Martin Bureau of ALTRA. Martin, take us away.
Thank you very much, Travis, for the intro. It's a great pleasure to be with you today. Good morning. My name is Martin Bureau. We're here to talk about our latest and greatest related to foam fractionation as a pre-treatment method for PFAS removal. The picture you're seeing here is a picture taken from our drone on our commercial site in Minnesota. I'll be talking about that later on. And this has been in operation for more than 6 months now. Why do I say pre-treatment? Because the authorities right now are considering foam fractionation and other such methods that do not destroy PFAS to be a treatment. So we don't mind calling that way as long as it works. Well, of course, we're past the introduction on PFAS, but why should we care about PFAS is an important topic. Recently, we've heard a lot of pushback on about authorities' treatment targets, which indeed are very low, perhaps too low. And people have said, why should we care anyway? And if you can't beat it, why caring? Well, there's a bunch of reasons why we should care, and that's one of them. I chose this slide from a Center of Disease Control and Prevention in the United States report on three common PFAS, legacy PFAS, that we find everywhere on Earth, and in this case, in the blood of US population. So it's a little small on the slide, but you see it, and I'll even take my glasses for it, but you see it in the blood of workers in Alabama, for example, in a plant that uses PFAS, and you see it in the same community, but non-worker population, of course. And then you'll have general population, and then various cities, and general US population. And this is concentration in microgram per liter of PFAS in the blood. And it ranges, I'll just summarize it, between 1,100 nanograms per liter, or 1.1 microgram per liter, if you prefer, to 941,000 nanograms per liter in blood levels. Now, for most of us, these concentrations don't make a lot of sense, or we don't understand what they mean. But when we worry about PFAS in a drinking water well, for example, the levels that are generally reported are below 200 nanograms per liter. Not 200,000, 200, whereas we find close to 1,000,000 nanograms per liter of those PFAS in the population of the US, and of course in Canada, where I am today. When we're treating highly concentrated liquid streams in the industrial effluent, we're worrying generally about 100,000 nanograms per liter. So in some population in the US and elsewhere in the world, the population is 10 times and even more, 100 times higher than in industrial stream, which is amazing. And that's, I think, by itself, something we should worry about. Now, on the financial aspect as well, we should worry, because, and this is a fantastic report by the Minnesota Pollution Control Agency. This is the cost to buy PFAS. It's about $50 to $1,000 a pound. Now, the cost to remove and destroy PFAS is something around 2.7 million to 18 million per pound. I'm going to cite the MPCA Commissioner Katrina Kessler. We need to address PFAS pollution long before it gets to the waste stream, because at that time it's way too diluted and way too expensive to treat. And it's not fair for wastewater treatment facilities and other such facilities like landfills, for example, to bury the cost of that pollution while they did not create it. They're not using PFAS, they're not producing PFAS, they're just receiving PFAS. And that's something we really need to address. And how should we? Well, and that, as Madame Kessler was saying, we need to address sources, and that's what the MPCA has done. We need to address sources at PFAS-producing plants, at landfills, which unfortunately are receiving PFAS, and firefighting areas, for example, and treat the streams that we get out of those. And that's exactly what ALTRA is about. ALTRA, for doing that, uses a foam fractionation technology. It's very different from others in the fact that it's continuous flow and that we recuperate all air that we use during the foam fractionation process. So there's no air and no PFAS emissions, and for that matters, no VOC, H2S or other emissions. The idea behind foam fractionation is to retrieve the PFAS from the water using a water column full of bubbles of air. And the PFAS tend to go at the interface between the air and the water. And if you extract a dry foam out of that column, a foam with the least water, then you get a lot of PFAS into it. Of course, you generate a concentrate or a foamate that needs to be either stabilized. People will use, for example, modified concrete encapsulation or destroyed. And ALTRA is piloting and is offering now, in partnership with technology providers, plasma destruction technology, electrooxidation technology, hydrothermal alkaline treatment, supercritical water oxidation, and of course, concrete encapsulation. The treated stream may go to a media for further filtration or polishing, GAC, resin, or our own media. And then you get a treated water. For doing that, we're using our center, the ALTRA PFAS Center of Excellence, where we've analyzed more than 14,000 PFAS samples so far. That helps us in developing new recipes, new formulation for our treatment, and of course, provide treatability studies to our client. And it's been, we're tested to, we use the test of the US EPA 533 and the others and the recent 1633 methods, of course. We're now commercial on, well, one operation currently and another being commissioned right now in Minnesota and New York, respectively. You see the pictures of the site. So our offer really is a water as a service solution. We don't sell an equipment and then you find how to operate it and handle it yourself. We're offering a guaranteed, actually the only guaranteed approach to PFAS treatment on those liquids. The picture you're seeing here are taken in Minnesota at the plant that the first non-pilot plant for treating PFAS in the US. That was put in service January 9th, 2024. It's designed to treat 25 million gallons per year of landfill leachate, a very complex contaminated liquid, and 72 gallons per day or 72,000 gallons per day or 55 gallons per minute, with a peak of around 90,000 gallons per day. As I said, we offer a process guarantee on total PFAS removal, pending on a definition of what is a treatable liquid, as you could imagine. The plant you're seeing here is equipped with climatization control, so for hot summer days and very cold winter, as you can get in Canada and northern US. And this plant, as of July 31st, 2024, has been treated 4,832,000 gallons of PFAS contaminated liquids. How does it do in terms of PFAS treatment? This is the removal rate of several type of PFAS. I didn't list all of them because that's a lot. The total PFAS content of raw leachate is around 20,000 nanograms per liter. Now it's going to vary at that site because we're about to commission an equalization tank to get the liquids from each of those cells at the site we're at in Minnesota. But right now we rely on individual streams that we get from some pumps at those cells. And so for this series of results shown here, the total PFAS content was 20,000 nanograms per liter. So much smaller than what we found on the US population blood in some cases, as I showed in the introduction. Short chain fraction for that liquid was 55 to 65%. When I say it's a complex liquid, it's one of those characteristics that shows it. The PFAS removal for several of those PFAS are shown here. And it varies. Some, we're doing okay, but we need to do better. It's 30 to 40% on PFHXA, for example. We're pushing the envelope quite significantly right now to introduce a new PFAS treatment module at the treatment. And we're very confident that it's going to do much better. But you see, for most of the other PFAS, we remove in excess of 85, 90, 95, and sometimes 99%. Now, of course, being that complex, we all aim at 99.9% and more. But we're improving the treatment, but it's getting there. So flow rate average 55 gallons per minute. On average, currently we treat 79,000 gallons per day. We generate 1 to 3% of fomate at those flow rates. Remember, flow rates and fomate generation goes hand in hand. You could have much smaller with much fomate generation, which much lower flow rate, or much larger footprint of equipment. And amazingly, we've treated almost 5 million gallons of liquid treated at that site so far, well above the targeted that we had planned, the targets that we had planned for that site in the first 6 months. So we're very proud of that, and our clients hopefully are as well. Like I said, we're improving on the treatment, introducing new prototype module for that treatment, and you see here, the type of liquid we were treating for those results. 66% for those particular experiments of short chain PFAS. You see the overall PFAS content was about 20,000. And the short chain removal with our new improvements are improved. Well, they go higher much significantly with 68%, an overall removal rate of close to 80% with long chain PFAS removal of 99%. So and that's the sum of all PFAS according to EPA 1633. Very proud of that. And our team, we've been piloting that all over the country, and hopefully we'll be mobilizing many more plants with industrial players or plants and landfill sites in the very future months. As a summary, our offer is a clean water as a service. It's turnkey solution, including destruction and encapsulation. I've shown here the results of foam fractionation. I did say earlier that we're offering now a full solution with the end of life of PFAS solutions pertaining to either encapsulation or destruction, depending on the client. We haven't produced the results yet. They're still under confidential agreement. What I can say is that our results for destruction out of those fomates, so we're destroying the fomates, are amazingly good. I'm even surprised with destruction rates at avoidable cost that are almost 100%, And when I say 100% is that we aim at least having the sum of all PFAS after destruction that remains, because destruction doesn't always destroy everything, below 1/50th, that's divided by 50 of the initial PFAS concentration and load. So, and if you do that, then you don't enrich. If you recirculate whatever is left in the treated fomate after destruction, you don't enrich your influent, if you like, with PFAS species that are difficult to treat. And we'll be presenting that momentarily. So our offer is simple. It's a design, build, operate, finance, and guarantee solution. We have our own in-house laboratory. We design our solutions. We build our solution. We do the investment. Our client doesn't have to pay until we start treating the liquids on a $1 per gallon basis, for example. We do the operation, the automation, and the maintenance, and we offer a guaranteed robust solution for the treatment. So the client can rest and deal with other challenges. This one we take care of. Key differentiator, lowest investment cost for our client. An highly customized approach that is modular. You can add to it. You're not stuck with it. You can improve as, for example, regulatory measures get stricter and stricter. It's a safe approach, both for the workers and the operators and the visitors. We have no emissions out of this treatment, no airborne PFAS water-containing PFAS water-containing droplets, or VOC H2S. This is the most robust approach. We can deal with all sorts of contaminants. It's not affected by the other contaminants or the co-contaminants that we find in the leachate. Foam fractionation and destruction is very, very effective. It's an operator-friendly design, automated, completely instrumented, and as I said, it's the only guaranteed solution on the market. So that's the end of my presentation. Thank you very much for listening in. I'm Martin Bureau, and I'm with ALTRA. Thank you.
Martin, thank you very much for the presentation. A lot of good information in there. If any of you would like more information from ALTRA about what Martin had just covered, please feel free to reach out to them on the contact information you see on the screen. Or, of course, you can always find more on ALTRA here at Water Online.